Hello, and welcome to Pilgrammed Math, where today I'll be exploring a fundamental question in Pilgrammed. The topic for today is, what is the complete damage formula in Pilgrammed? Now, in the last video, we concluded that the damage formula goes something like this: T times B minus D, where there are brackets around B minus D. However, you probably noticed that it's incomplete, because we didn't factor in piercing. So, for this video, my goal is to try to see how piercing affects the damage formula. So in our last video, we know that we can get an enemy's defensive stats by plotting an equation of straight line. So, through this logic, if we keep piercing as a constant, we can get the defensive stats of an enemy when piercing is applied. Alright, so let's do just that. We know that Haunted Site has a base damage of 36, but since it's legendary, I do 39.6 damage instead. Now, I have 0 stats. This is to ensure that I can just look at my base damage. And I'll be using Halberd and the legendary Haunted Site. Alright, so 39.6 damage becomes 16.42. Yep. Alright, and 36 damage becomes 14.52. Alright, so let's find the stats by plotting a graph. Alright, so after plotting these two data points on the graph, we can see that the equation of straight line is y equals 0.5277 repeating minus 4.48. Now, let's recall the damage formula. It is T times B minus D. We know that defense must be multiplied by damage taken, and we can determine the damage taken by looking at the slope of our equation, which is 0.5277 repeating. So, in order to find the new value for defense, we need to divide the y-intercept by the slope of the equation. And if we do just that, we get this value, which is around negative 8.48. Now, since defense can't be negative, we need to take the absolute value. Hence, defense should be around 8.48. Now, notice that this value is 85% of Observatory Dummy's original defense, which is 10. Also notice that 85% is 1 minus piercing, since we know that piercing is 15% as we kept it as a constant. Hence, let us assume that the formula for new defense is D times 1 minus P, where D is defense, P is piercing. So, let's get a new data point and see if we can verify this. Alright, so now that we're here, let's go back to an old friend of ours, Granny. Other than verifying our formula for defense after piercing is applied, we will also find out how her stats change when there's 15% piercing. Alright, let's go in. Okay. Alright, we have 39.6 base damage. I am using absolutely nothing. This is to ensure that I can just look at the base damage. Oh shoot. Alright, let's see how our damage changes. Alright, 39.6 damage becomes 23.51. And 36 damage becomes 20.93. Alright, let's do the exact same thing and plot a graph. Okay, so if we plot these data points on the graph once again, we get this equation of straight line. Using the same method, we can derive her defense, which is just the y-intercept divided by the slope. Alright, let's type that out really quickly. So, this divided by this. So, her new defense is around negative 6.79. Alright, so let's see if this matches up with our formula. We know that piercing was at 15%, and that Granny's defense is 8. Alright, so let's plug it in. 8 times 1 minus 0.15, it's 6.8. Notice that 6.79 is infinitely close to 6.8. Therefore, we can safely assume that this formula stands. Alright, so we've proved piercing affects defense. However, if we look back up here, notice that its slope has also changed. This means that the damage taken has also changed. So, how can we solve the change in damage taken when piercing is different? I leave this question to you. Or you can wait for part 2.